So we got another illustration which is based on previous concept, that is condition for tangency. Okay, now look at this. So for what value of lambda the line x plus y minus lambda equals to 0. So you got equation of line touches the circle x square plus y square minus 2x minus 2y equals to 0. Okay, so for this question I'll tell you how to solve by two different ways. Why? Because I want you guys to develop this kind of confidence. If you are lagging in any different idea, you can solve the particular question by different ways also. So look at this first approach. Okay, so in this part I will connect distance of center to the line. Okay, and I will connect with radius. So this is the case of what means I want the line to touch the circle, correct or wrong? Okay, so this means the distance between the point between the center and the line should be equal to radius. Is that okay? Now look at this. So can you please just look at this equation and tell me uh, the point center? Okay, so you know that you have to divide coefficient of x with 2 and then multiply by minus 1, so it is 1. Again do the same thing with this part as well. Divide coefficient of y with 2 and then multiply by minus 1, so this is your center. Okay, now I'll find the distance of this point from the given line. So it was what? Point satisfaction upon root over a square plus b square is equal to radius. And do you remember who is radius? It was g square plus f square minus c. Okay, so it is root 2. Okay, so do you know anything, any approach by which you can remove this mod and square root? Yes, very good, it is square. So can I write 2 minus lambda whole square upon 2 equals 2? So 2 minus lambda whole square will be equal to 4. So 2 minus lambda will be equal to plus of 2 or minus of 2. So lambda will be equal to what? For this case it will go this way, this thing will come this way, so it will become minus, so it will become 0. Now for this case it will go that side and this thing will come this side. So you got value of lambda as 0 and 4. Okay, I hope this concept is clear now. Okay, now look at this. So suppose that you got equation of line as this. Okay, and you got a curve, equation of curve. So this is your equation of curve. Now you want this straight line to touch the given curve. Touch means what? It will touch at single point, and if it will touch at single point, this straight line will behave as tangent for this given curve, correct? And how we will solve this question? So what you have to do, find value of y. So y will be equal to what? Lambda minus x. Now substitute value of y in the given curve. So it is x square plus lambda minus x whole square minus 2x minus 2 lambda minus x equals to 0. x square plus lambda square plus x square minus 2 lambda x minus 2x minus 2 lambda plus 2x. It should be 0 now. It is 0. Okay. Now look at this. You can simplify and try to create quadratic in x. So look at this. So these two things will get clubbed and it will become 2x square. Now minus of 2 lambda x and then minus 2 lambda minus lambda square equals to 0. So you got quadratic in x. Now you know that this straight line is touching. Touching means what? One real root. And if it is quadratic, you cannot have one real root. It is real and equal root. So what we have to do? We have to make d to be 0. So it is b square minus 4ac. Okay. Now look at this. So it will become what? 4 lambda square plus 16 lambda minus 8 lambda square. Okay. Now look at this. You can club these two things and we will be left with 16 lambda minus 4 lambda square. Now can I divide both sides by minus 4? So we will have lambda square minus 4 lambda. And again take lambda common. So lambda minus 4 equals to 0. So we got lambda value as 0 and 4. Now look at this. By this method also you got the same values of lambda. Okay. So in any method, if you are comfortable, just trust your instinct and approach your question. Okay. But try to avoid making calculation mistake. Okay. I hope this concept is clear now. We will go with another similar kind of illustrations for better understanding. Okay.